School of Management Studies IGNOU presents an audiobook on the course MMPC 008 Information Systems for Managers for MBA program. Block 4 Support Systems for Management Decisions. Unit 13 Data Warehousing and Data Mining. Part 3.
Data visualization. Business decision makers use data to identify opportunities, trends, and areas of concern in their respective businesses. Most data reaches the users in the form of tabular reports, which they find challenging to quickly and effectively absorb the information, spot patterns, identify aberrations, and see hidden relationships. On the other hand, the trained human eye can easily spot patterns that the most advanced analytical tools would not be able to detect. Fortunately, though the volume of data the users need to deal with is ever expanding, data visualization tools have been evolving to the point that they can now transform large quantities of complex data into meaningful visual representations that incorporate the science behind human perception and cognition. As the old saying goes, a picture is often worth 1,000 words, or in this case, 1,000 rows of data. Data visualization applications render large quantities of data in the form of basic charts, graphical indicators, scorecards, dashboards, advanced visualizations, animations, and virtual reality environments. By automating the fundamental aspects of data analysis, they help information users identify trends and patterns in data that are often not apparent in traditional tabular representations. Managers have found these applications very effective for viewing business activity at a glance. Data visualization involves graphical image generation by software, where the content of the image is determined by reading digital data. The data is usually numeric, but some software can visualize concepts drawn from text documents. The software arranges geometric shapes to create an interpretation of the data it read. Attributes such as proximity, size, and color express relationships between the geometric shapes. Data visualization has gained adoption among business users because it supports a variety of business tasks, including decision-making, knowledge management, and business performance management. 3 strong trends have shaped the direction of data visualization software for business users over the last few years. Chart types. Most data visualization depend on a standard chart type, whether a rudimentary pie chart or an advanced scatter plot. The list of chart types supported by software has lengthened considerably in recent years. Level of user interaction with visualization. A few years ago, most visualizations were static charts for viewing only. At the cutting edge of data visualization today, dynamic chart types are themselves the user interface, where the user manipulates a visualization directly and interactively to discover new views of information online. Size and complexity of data structures represented by visualization. A rudimentary pie or bar chart visualizes a simple series of numeric data points. Newer advanced chart types, however, visualize thousands of data points or complex data structures such as neural nets. Rudimentary forms of data visualization, pie and bar charts and presentation graphics, have been available in software for many years, whereas advanced forms with interactive user faces, drill down and live data connectivity are relatively new. The wide array of visualization software supports many different chart types because the need of users vary gently. For example, business users demand pie and bar charts, whereas scientific users need scatter plots and constellation graphs. Users looking at geospatial data need maps and other 3-dimensional data representations. Digital dashboards are popular with executive business intelligence users who monitor organizational performance metrics, visualizing them as speedometers, thermometers, or traffic lights. Tools for charting and presentation graphics are devoted exclusively to visualizing data. However, data visualization capabilities are commonly embedded in a wide range of software types, including tools for reporting, OLAP, text mining, and data mining, as well as applications for customer relationship management and business performance management. Business software for charting has evolved from static and superficial charts to interactive visualizations with data connectivity and drill down. These advanced capabilities are found in a new category of software, the Enterprise Charting System, ECS. With an ECS, users can develop and deploy chart-centric analytic applications that provide data visualization specifically for business intelligence on an enterprise scale. Data visualization has long been in use in software for the study of mathematical, statistical, geographic, and spatial data. Some data visualization software for business users has borrowed chart types originally designed for scientific users, such as scatter plots and constellation graphs. Whereas scientific users tolerate heavily technical functionality that may require knowledge of programming languages or statistics, business users need this functionality to be hidden under a friendly user interface. For data visualization to appeal to business users, it must provide out-of-the-box value in the form of functionality for solving business problems such as analyzing or mining customer behavior, product categories, and business performance. What is good visualization? Effective, ease of interpretation, accurate, sufficient for correct quantitative evaluation, aesthetics, must not offend viewers' senses, adaptable, can adjust to serve multiple needs. Human perception capabilities and the fact that all displays need to be mapped to a two-dimensional flat computer screen or sheets of paper impose many limitations. For example, according to one researcher, inaccuracy of human perception increases in the following order when the respective techniques are used for visualization: position along a common scale, position along identical non-aligned scales, length, angle or slope, area, volume, hue or saturation, or intensity. The techniques commonly used to overcome the limitations of two-dimensional displays and size restrictions are scaling and offset to fit in range, derived values to emphasize changes, projections and other combinations to compress information, random jiggling to separate overlaps, multiple views to handle hidden relations, high dimensions, effective grids, keys, and labels to aid understanding. Data mining. According to Perry and Linoff, data mining is the exploration and analysis by automatic or semi-automatic means of large quantities of data in order to discover meaningful patterns and rules. This definition, justifiable, raises the question, how does data mining differ from OLAP? OLAP is undoubtedly a semi-automatic means of analyzing data, but the main difference lies in quantities of data that can be handled. There are other differences as well. Why now? Why data mining is being put to use in more and more businesses? Here are some basic reasons. In today's world, an organization generates more information in a week than most people can read in a lifetime. It is humanly impossible to study, decipher, and interpret all the data to find useful patterns. A data warehouse pools all the data after proper transformation and cleansing into well-organized data structures. Nevertheless, the sheer volume of data makes it possible for anyone to use analysis and query tools to discern useful patterns. In recent times, many data mining tools suitable for a wide range of applications have appeared in the market. The tools and products are now mature enough for business use. Data mining needs substantial computing power. Parallel hardware, databases, and other powerful components are available and are becoming very affordable. Organizations are placing enormous emphasis on building sound customer relationships, and for good reasons. Companies want to know how they can sell more to existing customers. Organizations are interested in determining which of their customers will prove to be of long-term value to them. Companies need to discover any existing natural classifications among their customers so that each such class may be properly targeted with products and services. Data mining enables companies to find answers and discover patterns in their customer data. Finally, competitive considerations weigh heavily on organizations to get into data mining. Perhaps competitors are already using data mining. Data mining techniques. Data mining covers a broad range of techniques. Each technique has been heavily researched in recent years, and several mature and efficient algorithms have evolved for each of them. The main techniques are cluster detection, decision trees, memory-based reasoning, link analysis, rule induction, association rule discovery, outlier detection and analysis, neural networks, genetic algorithms, and sequential pattern discovery. Discussion on the algorithms associated with the various techniques has been kept outside the scope of this text for two main reasons. Firstly, because they are too mathematical, technical in nature, and secondly, because there are numerous well-written textbooks to serve the needs of those who are specially interested in the subject. The model structure refers to how the technique is perceived, not how it is actually implemented. For example, a decision tree model may actually be implemented through SQL statements. In the framework, the basic process is the process performed by a particular data mining technique. For example, the decision trees perform the process of splitting at decision points. How a technique validates the model is important. In the case of neural networks, the technique does not contain a validation method to determine termination. The model calls for processing the input records through the different layers of nodes and terminate the discovery at the output. Data mining applications. Data mining technology encompasses a rich collection of proven techniques that cover a wide range of applications in both the commercial and non-commercial realms. In some cases, multiple techniques are used back to back to greater advantage. For instance, a cluster detection technique to identify clusters of customer may be followed by a predictive algorithm applied to some of the identified clusters to discover the expected behavior of the customers in those clusters. Non-commercial use of data mining is strong and pervasive in the research area. In oil exploration and research, data mining techniques discover locations suitable for drilling based on potential mineral and oil deposits. Pattern discovery and matching techniques have military applications in assisting to identify targets. Medical research is a field ripe for data mining. The technology helps researchers with discoveries of correlations between diseases and patient characteristics. Crime investigation agencies use the technology to connect criminal profiles to crimes. In astronomy and cosmology, data mining helps predict cosmic events. The scientific community makes use of data mining to a moderate extent, but the technology has widespread applications in the commercial arena. Most of the tools target the commercial sector. Consider the following list of a few major applications of data mining in the business area. Customer segmentation. This is one of the most widespread applications. Businesses use data mining to understand their customers. Cluster detection algorithms discover clusters of customers sharing the same characteristics. Market basket analysis. This is very useful application for the retail industry. Association rule algorithms uncover affinities between products that are bought together. Other businesses such as upscale auction houses use these algorithms to find customers to whom they can sell higher value items. Risk management. Insurance companies and mortgage businesses use data mining to uncover risks associated with potential customers. Fraud detection. Credit card companies use data mining to discover abnormal spending patterns of customers. Such patterns can expose fraudulent use of the cards. Delinquency tracking. Loan companies use the technology to track customers who are likely to default on repayments. Demand prediction. Retail and other businesses use data mining to match demand and supply trends to forecast for specific products. The data mining project. Step 1. Define business objectives. This step is similar to any information system project. First of all, determine whether a data mining solution is really needed. State the objectives. Are we looking to improve our direct marketing campaigns? Do we want to detect fraud in credit card usage? Are we looking for associations between products that sell together? In this step, define expectations. Express how the final results will be presented and used. Step 2. Prepare data. This step consists of data selection, pre-processing of data, and data transformation. Select the data to be extracted from the data warehouse. Use the business objectives to determine what data has to be selected. Include appropriate metadata about the selected data. Select the appropriate data mining techniques and algorithms. The mining algorithm has a bearing on data selection. Unless the data is extracted from the data warehouse, when it is assumed that the data is already cleansed, pre-processing may be required to cleanse the data. Processing could also involve enriching the selected data with external data. In the pre-processing sub-step, remove noisy data, that is, data blatantly out of range. Also ensure that there are no missing values. Step 3. Perform data mining. Obviously, this is the crucial step. The knowledge discovery engine applies the selected algorithm to the prepared data. The output from this step is a set of relationships or patterns. However, this step and the next step of evaluation may be performed in an iterative manner. After an initial evaluation, there may be need to adjust the data and redo this step. The duration and intensity of this step depend on the type of data mining application. If the database is being segmented, not too many iterations are needed. If a predictive model is being created, the models are repeatedly set up and tested with sample data before testing with the real database. Step 4. Evaluate results. The aim is to discover interesting patterns or relationships that help in the understanding of customers, products, profits, and markets. In the selected data, there are potentially many patterns or relationships. In this step, all the resulting patterns are examined and a filtering mechanism is applied so as to select only the promising patterns for presentation and use. Step 5. Present discoveries. Presentation of patterns, associations discovered may be in the form of visual navigation, charts, graphs, or free-form text. Presentation also includes storing of interesting discoveries in the knowledge base for repeated use. Step 6. Ensure usage of discoveries. The goal of any data mining operation is to understand the business, discern new patterns and possibilities, and also turn this understanding into actions. This step is for using the results to create actionable items in the business. The results of the discovery are disseminated so that action can be taken to improve the business. Selecting data mining software tools. Before we get into a detailed list of criteria for selecting data mining tools, let us make a few general but important observations about tool selection. The tool must be able to integrate well with the data warehouse environment by accepting data from the warehouse and be compatible with the overall metadata framework. The patterns and relationships discovered must be as accurate as possible. Discovering erratic patterns is more dangerous than not discovering any patterns at all. In most cases, an explanation for the working of the model and how the results were produced is required. The tool must be able to explain the rules and how patterns were discovered. Let us complete this section with a list of criteria for evaluating data mining tools. The list is by no means exhaustive, but it covers the essential points. Data access. The data mining tool must be able to access data sources, including the data warehouse, and quickly bring over the required data sets to its environment. On many occasions, data from other sources may be needed to augment the data extracted from the data warehouse. The tool must be capable of reading other data sources and input formats. Data selection. While selecting and extracting data for mining, the tool must be able to perform its operations according to a variety of criteria. Selection abilities must include filtering out of unwanted data and deriving new data items from existing ones. Sensitivity to data quality. Because of its importance, data quality is worth mentioning again. The tool must be able to recognize missing or incomplete data and compensate for the problem. The tool must also be able to produce error reports. Data visualization. Data mining techniques process substantial data volumes and produce a wide range of results. Inability to display results graphically and diagrammatically diminishes the value of the tool severely. Extensibility. The tool architecture must be able to integrate with the data warehouse administration and other functions such as data extraction and metadata management. Performance. The tool must provide consistent performance irrespective of the amount of data to be mined, the specific algorithm applied, the number of variables specified, and the level of accuracy demanded. Scalability. Data mining needs to work with large volumes of data to discover meaningful and useful patterns and relationships. Therefore, ensure that the tool scales up to handle huge data volumes. Openness. This is a desirable feature. Openness refers to being able to integrate with the environment and other types of tools. The ability of the tool to connect to external applications where users could gain access to data mining algorithms from the applications is desirable. The tool must be able to share the output with desktop tools such as graphical displays, spreadsheets, and database utilities. The feature of openness must also include availability of the tool on leading server platforms. Suite of algorithms. A tool that provides several different algorithms rather than one that supports only a few data mining algorithms is more advantageous. Multi-technique support. A data mining tool supporting more than one technique is worth consideration. The organization may not presently need a composite tool with many techniques, but a multi-technique tool opens up more possibilities. Moreover, many data mining analysts desire to cross-validate discovered patterns using several techniques. Benefits of data mining. Without data mining, useful knowledge lying buried in the mountains of data in many organizations would never be discovered, and the benefits from using the discovered patterns and relationships would not be realized. What are the types of such benefits? We have already touched upon the applications of data mining and have indicated the implied benefits. Just to appreciate the enormous utility of data mining, the following list enumerates some real-world situations. In a large company manufacturing consumer goods, the shipping department regularly short ships orders and hides the variations between the purchase orders and the freight bills. Data mining detects the criminal behavior by uncovering patterns of orders and premature inventory reductions. A mail order company improves direct mail promotions to prospects through more targeted campaigns. A supermarket chain improves earnings by rearranging the shelves based on discovery of affinities of products that sell together. An airlines company increases sales to business travelers by discovering traveling patterns of frequent flyers. A department store hikes the sales in specialty departments by anticipating sudden surges in demand. A national health insurance provider saves large amounts of money by detecting fraudulent claims. A major banking corporation with investment and financial services increases the leverage of direct marketing campaigns. Predictive modeling algorithms uncover clusters of customers with high lifetime values. A manufacturer of diesel engines increases sales by forecasting sales of engines based on patterns discovered from historical data of truck registrations. A major bank prevents loss by detecting early warning signs for attrition in its checking account business. A catalog sales company doubles its holiday sales from the previous year by predicting which customers would use the holiday catalog. Summary. Information for strategic decision-making is of utmost importance to organizations. Due to several practical difficulties with the structure and nature of data held in operational systems in generating the required information and availability of secondary data worldwide, the concept of data warehousing has emerged. In the data warehousing environment, data collected from internal operational systems as well as data from external sources is loaded into a subject-oriented, time-variant, integrated, and non-volatile environment. The data warehouse environment is carefully designed with time span, granularity, aggregations, dimensionality, and partitioning in mind. The initial data feed to the data warehouse as well as regular loading of data takes place in 3 phases: extraction, transformation and loading, and is done by load manager component of the data warehouse. The data in the data warehouse is organized in terms of fact data and dimension data. The star and snowflake schemas used in data warehouse support the separation of fact data and dimension data as well as efficient query processing. Metadata or data about data is an indispensable and integral component of a data warehouse. Data collected from external sources can supplement internal data and prove extremely valuable. The concept of collecting information from the web primarily for loading into an organization's data warehouse is known as web farming. Online Analytical Processing (OLAP) technology provides multidimensional analysis capability to the users of a data warehouse. It also provides an interface through which other client software can access the data warehouse. Data visualization technology has made great progress in recent years. It can act as an important tool in the hands of trained users by providing valuable support to spotting trends or deviations in data. Apart from OLAP and data visualization tools that are user-driven, semi-automatic tools for data analysis, another class of tools that are more automatic in their analysis and at the same time capable of accessing and using large volumes of data, have matured recently. This category of tools, known as data mining tools, have found applicability in many business areas. A variety of data mining techniques and algorithms are available for data exploration and discovery of novel patterns and relationships. The business benefits derived from the discoveries made by the data mining tools could be immense.
We were listening to the audiobook by the School of Management Studies IGNOU for MBA program, course code MMPC 008, Information Systems for Managers. Course Coordinator, Professor Anurag Saxena, School of Management Studies IGNOU. Voiceover by Renuka. Edited by Uday Sharma. Program assisted by Jagbandhu Jana. Program produced by Dr. Manoj Kumar Singh. This program was brought to you by Electronic Media Production Center of Indira Gandhi National Open University.